topic. So today we're going to talk about MATLAB function. Okay? So as I said from last lecture, we talk about maybe when you make a MATLAB code, you may have some part is heavily repeated. Okay? For example, you do a repeated computation, that math part, you always some part is repeated, and how to make the MATLAB file simpler. Normally, we replace that part using MATLAB function. Okay, so MATLAB function is the function you're gonna create yourself. So MATLAB function is not a built-in function. So built-in function, for example, we talk about sine, cosine, log, exp. This kind of built-in function is some function that's already in MATLAB. So you just call the built-in function, you can run. Okay? So today's lecture, we're going to talk about the MATLAB function is the function you're going to build up, and why we need MATLAB function, and how we're going to handle MATLAB function. Okay? So we start from an example. This example probably frequently appear in our lecture notes, and also maybe in your lab. So this example is to saying we are try to compute a sine wave. So for a given input argument x, okay. So sine of x is equivalent as the right-hand side equation. That equation is called Taylor series expansion. So sine wave can write using a Taylor series expansion, cosine wave also, and so on. So for this sine wave, if you use the Taylor expansion, basically it's a sum of this part. And the summation is going to be n is from 0 to infinity. You have an infinite, on theory, it's infinite sum. Okay? So in reality, that when you make MATLAB codes, you can't make an infinite sum. Okay? So everything becomes finite. So how do we do this? For example, our MATLAB codes here is actually a finite sum. Only take the first two terms. The first two terms is when n start from 0, and the next term is when n equals 1. So you just plug in this part, this math part, and do a computation. So therefore, the MATLAB codes that we wrote is given here. First, assign x from negative pi to pi with this step. So x is a vector. And then assign 0 to n. And then we compute this part. This part, the computation is exactly this part, the part I marked star here. Okay? So you compute with n equals 0. So the output you assign to the variable sine n0. So then you change n, you reassign n by 1, and then do the same computation. And the output you assign to sine n1, and then you just sum them. This first two terms summation of the Taylor series for sine x. So now we come from the problem is the first two terms probably is not so enough, because you may incur many terms. So if you want to make it accurate, so normally what we do is take quite a few terms. So n equals 0, 1, 2, 3, 4, and so on. So here is, for example, we take the first 5 terms. N is enumerated from 0 to 4. And basically, you're doing the same computation every time and assign to a different variable. And then the final answer is the sum of all these 5 variables. So then this program is quite inefficient, because every time you're repeating the computed part, the math part, every time. You repeat it 5 times. So that is why this motivation is start from this. So because you are trying to avoid this repetition pattern. So what you're going to do is you write a MATLAB function to replace this math part. And every time when you want to do this computation, you call this MATLAB function. And then just make your MATLAB code shorter, efficient. Okay? So now we see how we make a MATLAB function. So first thing we need to do is grab the repeated math part. So what is really repeated? It's this part, this MATLAB line. Okay, this MATLAB line, you find the corresponding math being repeated. So the Taylor expansion, this summation, the inside of this orange box is the math part that you repeated every time. Okay, so what we're going to do before we make a MATLAB function, so what we're going to do is to create a diagram to show the logic. Okay? So first we create a diagram. So first we create this black box. Okay? This black box, so what you're going to put in is the math part being repeated. Okay? So here is this math part being repeated. So we put it in. So here is -1 to the power square times 2n plus 1 factorial times x to the power of 2n plus 1. This is math part being repeated. Now, imagine if you want to make this part as a MATLAB function. You need some input, right? Because this math part, what do you need as an input? You don't know n, okay? You don't know x. So what you're going to do is this. Going to compute what's inside the black box, you need two input. One is n, one is x. So normally we call this input value called argument. Okay? And what is the output? Output is simply the computation result. So now this we normally call function's return value. So why this diagram important is because you're going to sort out the logic. Okay, you have a black box, you want to compute this part, you have an input here, you have output here. Okay, so after you sort out this thing, then followed by what? So now, after you sort out this logic, then we're going to write a MATLAB code. So how do we write a MATLAB code? So first thing we need to do is create a new script. So you create a new MATLAB script. Okay? So when you create this new script, so the first line that you want to put in this MATLAB script is you type in function. So when you type in function, MATLAB will understand that you are building a MATLAB function. So when you type in this function color, this letter color will turns into blue, because MATLAB means MATLAB understand and it's ready. Okay. So after this function, followed by this result, we call the return value. So return value, normally you create a name. You create a name, and that name will represent the result. Okay? This variable name, up to you. You create the name that you want. Okay? So this is a variable to represent this return value, and then it was assigned to, followed by, this is a function name. So this function name is also you create. You can design. For example, I call this sign Taylor. This is function you choose, function name you choose. Okay, but this name here, when you choose the name, or when you put the name by yourself, the name must not be coincide with building function, because otherwise you will overwrite building function. Okay, so normally this, when you create this name, so try to make it not sine or cosine or log or this kind of sensitive built-in function name. And then followed by input arguments. Okay? So then you complete this line. So this line is called function declaration. So the first line is to declare you're writing a function. And the first one is return value followed by function name with input arguments. So after this first line, you declare a function. You also declare that this Taylor result is a return value. So if you declare this is a return value, then you must assign some computation to this return value. That's the second line. Okay? Second line, you assign this repeated math part to this return value. So then you complete a MATLAB function. Okay? So MATLAB function basically involves two parts. First part is function declaration, and then second part, you're trying to assign the return value some math computation. Okay? So this is an example. So how to build function. So now I'm going to show you this function. So this is exactly the function we're talking about. Okay? Return value, sign Taylor is function name with the input arguments. And in between, you can, like I introduced last lecture, the good programming skill. So in between, you should make documentation. That documentation normally is author, dates, and what is about. And for function, you can even give more detail about what is the input argument, what is the return value, and etc. So when you put this, and if you know and you don't want to really see it, you can click here. Okay? So then it shrinks to only one line. So this is the how to create MATLAB function. And this is the documentation. So now I'm going to demonstrate you how to call this MATLAB function. So we only talk about how to create MATLAB function. Now you can call the MATLAB function. Okay? So when you call the MATLAB function, there's two ways of calling MATLAB function. One way is you can type in the command window. When you need this MATLAB function, you can call from command window. But when you call from command window, there's one thing that you need to pay attention to is here, the folder. Okay? This folder should be the same folder as the MATLAB function stored folder. Okay? So now I made it the same. So now I can basically I can call the function x. I want to have minus pi to pi. Okay? So I think I lost connection. So, okay, x is from minus pi to pi with step 0.1. And now I call MATLAB function. MATLAB function, there is one way, very easy to call MATLAB function, is just copy this function declaration line without function, without the first one. So you paste here. So x you already assigned n. How many terms you want? Let's make it 5. So first 5 Taylor series terms, you want to sum them together. So this is calling this function, and the output is Taylor result. So that's the output. Okay? So I figure out this is what I used to do, because sometimes when you call this MATLAB function, and for example, you can also call this by saying, also you can do this, sign Taylor x and 5. You can also do this way. Just directly type in function name with input arguments. It also works the same. The reason I prefer to copy this line is because in case you have typos. So in this way, you guarantee you don't have typo. So but it's up to you. So this is one way to call the MATLAB function from command window. There's another way to call the MATLAB function. Is you create another MATLAB file, and inside MATLAB file you can call the MATLAB function. It's basically similar idea from command window. It's the same thing. So now I show you this example. This example is x is from -pi to pi with step 0.1, and so here you call this MATLAB function. Like I said, you just call this function name with input argument. So it's always work like that. Okay. So input x, and here the second position is n. N is 0. First term, and then second term, third term, and so on. You add them, the first 6 terms together. So there's one thing I want to point out is here. So when you have a line very long, and you want to break it, but you also want to MATLAB know that this line is actually continue to the next line, you put 3 dot. So this MATLAB will know this command line extended to next line. So this is the two way of calling a MATLAB function. And now we see an example. So for this example, we are going to write a MATLAB function for this example. So this example is saying you have a tank. You're consulting for a company and designing this kind of tank. And this tank have a fixed height and a variable radii, and ask you to write a MATLAB function to calculate the volume of this tank with different radii. Okay? You remember how to compute the volume of a tank? Okay. So you have a tank here. Radius r, height h. Okay? So the volume is simply pi radius square times h. Okay? This is the math that you want to use. So what is the input? The input is giving you a fixed height. This is a variable radii. So this is a vector. This is it's just a fixed height. It's just a number. This will be a set of numbers. Okay. So what is the output? Output is just volume. So from input to output, which math you're computing is just given here. So now we are ready to build the diagram for the MATLAB function. So what do you have here? As I said, make a box, and inside the box is the math you're going to use. Okay? So what is the input arguments? H and the radii. What's the output? Volume. So you have input arguments, return value, the math you're going to do. So now we build a MATLAB function. So when we build MATLAB function, you create a new MATLAB script, and in the first line we write function. You declare it's a function with a space. So the return value, for example, we said is V, volume. And you can call this function tank volume, okay? Followed by input argument, H and R. So as I said, this is output, okay? Output V should assign some math computation, which is pi times R to the power of 2, because R is a set of radius. So it's a vector. So vector power is r dot power 2 and multiply h. And these two lines give you this MATLAB function. Okay? So any question about this? Okay, this is my scratch, and I just want to explain that build a diagram first and then write these two lines is very easy. And in fact, here is the MATLAB function, okay, that I've just built. So now this is an example, and of course you can call the MATLAB function from the command window. Connection stopped again. Okay, so now we can call this MATLAB function actually. So there's a, let's call this MATLAB function the radii. We can say it's 1, 2, 3. Varies from 1 meter, 2 meter, 3 meter. And the height, let's say 10 meter height. So this will directly give you the volume. Okay? So this is the calling this function. So now we showed two examples for MATLAB function. So last example. Last example is talking about a mining vehicle. So this mining vehicle, actually this picture is taken in Victoria mine. So normally when you have a mining business, you have many dust when you dig a mine, many dust and waste. So normally you use this kind of mining vehicle to remove the dust. So this mining vehicle, we have these rounds with many buckets. So you rotate. This will be someone press a button and they will rotate, and then the bucket will carry all this waste. And then it have a convenient belt. So the waste will delivered back to some collection truck and then shipped somewhere else. Okay, so this truck is quite big. It's 95 meters tall, 220 meters long. Okay, so this is so heavy and need 5 people to operate. So our question example is related to this big vehicle. So this example problem is given you. So now imagine you're working for this company and use this vehicle, and they want you to have a risk, to know the risk that if debris fall from the convenience belt, okay, so the height can change. So imagine this is this heavy bucket, okay, and the shift from convenient belt. So this height is given, okay, but it varies from day to day. And ask you that calculate the time it takes debris to hit the ground and the velocity of debris when it hits the ground. So actually only give you height and ask you calculate the time and the velocity. Okay, and then our aim is to write a MATLAB function for this case. So let's formulate the problem. So here D represents the height of convenient belt. This is D. Okay, so the time that debris hit the ground, it took using this equation. So, and then the velocity is just gravity multiplied time. So now we have this math computation. So just we follow the previous what we discussed, that we're gonna build this MATLAB diagram. So what you're gonna compute is these two. So you are going to compute 2D divided by G and GT. So now tell me, what's the input arguments? Input arguments is the height. Okay. Is that gravity also input argument? Normally, we don't put this kind of well-known constant to input arguments. So here, gravity will not be the input arguments. However, you can define inside the MATLAB function. Okay? So the output, what is the output? You have two outputs. You have T and you have V. This is the return value. Okay? So with this input, this math you're going to repeat, this output, we can write a MATLAB function. This example different from the first example, the tank volume, because the tank volume is like 2 input, 1 output. This is 1 input, 2 output. So it's sometimes when you build a MATLAB function, the number of input, number of output, sometimes is different. So this is example just show you when you have multiple output. So now, so we have this mass computation is 2D divided by gravity and GT. This is for the speed and this for the time. Okay? And the input argument we said is the distance or the height. Okay? And the output is time and velocity. So again, we follow the same procedure, create a new MATLAB script, and then write MATLAB function declaration. Function followed by the output, the return value. So because you have 2 output here, so the return value, when you define the variable, you have 2 variables. One is time, one is velocity. As I said, the name, you can make the name yourself. And they are separate, normally separate with a comma between and with the square brackets. And followed by the MATLAB function name, okay? And with the input arguments. So inside this MATLAB function, as I said, the gravity, first we define the gravity, and then we compute the time and velocity using these 2 equations. So there is a mistake here. I think this should be gravity multiply this drop time using this equation. This equation was not correct. So this is the MATLAB function for the second example. Now I'm going to show you here. Okay. So this is basically, this is exactly what we just commented. And with the time, velocity, and debris drop with these input arguments. Gravity, dropping time, velocity computation. So it's quite straightforward. And don't forget, put between function and a few extra lines of documentation right after this function declaration to tell you what it's about. And so now we wrote this function, and we're going to call this function. So what we can do is, again, you can copy this line. Okay? So what you need to do is just give the convenient height. You can directly put in the value you want to input. So I'm going to put a vector. So from 1 meter, 2 meters, 3 meters. So this is input argument. We call this function, and the return value give to drop time, drop velocity. Okay? So you can just run it. And then you can see what is drop time. It gives you here. And the drop velocity. Okay? So also, when you call, you can also directly call the file name. Instead of seeing this, you just directly saying 1, 2, 3, input. Okay? So normally, the printout is the first drop time. Let velocity. They also have velocity, but if you didn't specify the output, they only print out the first return value. But of course, you can call the second return value and check what it's about. Yes.
Are these functions, are they defined only in your M file, or are they stored to the library of functions?
I think only in your M file. And
if you close your M file and got rid of it in the directory, and you try to do that again, it wouldn't work.
oh, you mean that?
Yeah.
Let's try it. It won't work probably this way. It won't work. If I clear all, close all. Debris drop. That means it's stored there.
Okay.
Yeah. But when you call this again, the current folder should be the same as MATLAB folder. If you make the command window not in the current, not in the same folder, you can't call them. Okay. So this is the. Okay, this is pretty much for today. And next lecture, we're going to talk about the input and output. So I have a great weekend. I will see you next Tuesday.